Hello. Yeah. So hello everyone. This is the tutorial for week 3 digital circuits. The instructor is Professor Shantanu Chattopadhyay and myself, Sai Shubham, and I am in PhD second year. I am pursuing my PhD in electrical engineering from IIT Gandhinagar. Okay. So this is the first question. The question is the canonical sum of products form for the expression given here. Okay. So there are four options, and I will give you 5 minutes to solve this. Okay. Or I will discuss the solution in next 3 to 4 minutes. I expect everybody to solve this question. This is a very simple question. So is there anyone else trying, or should I wait, or should I discuss the solution? Okay, so let's discuss the solution then. So the expression is, so in sum of products, it is any expression which is of the form signal 1 and gate signal 2 and gate signal 3, which is then odd with another signal. Fine. For example, as you can see that these two signals are first performed are first passed through AND gate, okay, and then the output signal is passed through an OR gate, okay. But the problem with this is that this is not the standard sum of products expression. So for that, the reason it is not a standard is that, as you can see, there are four variables, okay. So in each term, all four signals. Since I am from electrical background, so I call it signals, but these are basically variables. Okay, so all four signals or variables must be present. So how do we do that? So we know about this, that any signal when odd with its complement is always 1. So as you can see, this expression as yz, which is y and z. Okay, so I can assume that there is this another signal x plus x dash. Fine. Similarly, there is another signal y plus, sorry, w plus w dash. Okay, so if you notice, the LHS is equivalent to RHS. Okay, I hope everybody agrees with this. There is no confusion, because if you simplify this expression, it will eventually give you yz. Okay, so we can write this interchangeably. Now, for w dash x dash, we can write as w dash x dash plus y dash into z plus z dash. Okay, this will simplify to yz xw plus x dash w plus x w dash plus x dash w dash, which is equal to w x yz plus w x dash yz plus w dash xyz plus w dash x dash yz. Similarly, this is equal to w dash x dash yz yz dash plus y dash z plus y dash z dash. Okay, so this is w dash x dash yz plus w dash x dash yz dash y dash z plus w dash x dash y dash z dash. Okay, so now we have to look if there are any common terms. Okay, suppose one signal is high, if we add it with that signal only, it will remain the same. Okay, if we add it with its complement, it will become 1. If we AND it with its complement, it will become 0. Okay, so this is the basic Boolean logic. We have more, like x plus 0 is still x, x plus 1 is equal to 1. Fine. So we will make a, so as you can see now, this is 0 0 0 0. Okay, this is 0, this is actually 1 1 1 1 1 1 1 1 0 1 1. Yeah, this is 0 0 0 1 1 1 0 0 1 0 0 0 0 1. So how many terms are there? There is 0, there is 1, there is 2. This is 0, this is 1, this is 2, this is 3. Okay, this is 3 as well, this is 7, this is 15, and this is what, 8 plus 3 11. Okay, so we have 0 1 2 3 7 11 and 15. So this is the answer, B. Okay, I hope everybody got this. So moving on to the next question. uh, is it clear for everybody? Like, should I proceed? Okay, fine. Moving on to the next question. Okay, so this is the question. Given a sum of product expression, you are expected to find what is the equivalent product of some expression. And the point to be noted is that these all are product of some expression, but these are not standard product of some expression. Okay, so in all the standard expression, in each min term or max term, you will find all the signals or all the variables. Okay, so that is the difference. So I will give you 5 minutes for this. So this is a very simple question. I expect everybody to solve this. Okay. I will discuss the solution in 1 minute. Fine. So the simple way would be to um, simplify each expression. Okay. So let's take option A. Actually, you can discard the option A just by looking at, because in the, like, the requirement is AB plus CD. Okay, as you can see here, A and B, there is an OR operation. Okay, and here also there is OR operation, and here we are performing the AND operation, right? So for A and B, so the AND operation to happen between A and B, so these signal should not be in the same bracket. Okay, either had it been like this, there would have been a possibility that A would be multiplied with B, okay, and C would be multiplied by D. Okay, since this is not possible, so by looking at this, you can say that this option is not correct. Okay, let's see another option. Option C. Same logic. Uh, A and B are, there is OR in the, there is OR operation between A and B, and only AND operation exists here. So A cannot be multiplied with B because B is absent uh, in the other expression. Okay, in the other term, so B is absent. So AB not possible. Let's look at option D. So A plus B, C plus D, B plus D. Okay. So here there is a possibility that A can multiply itself with B. C can also multiply itself with D. Okay. So we have to simplify this expression. Okay. Now this is basically BC because you can take BC common, BC into 1 plus D. This will be 1 only. Okay. Similarly, this will be AB only. Okay. Now what else? So it will simplify as ABC plus ACD plus BD plus AB plus BC. Okay. So now pair these two, fine, and we can pair BC. If we pair these two, we will get BC because it will be BC 1 plus A, right? So this will be only 1. So BC plus BD plus AB plus ACD. Okay. So we can take B common. So it will be B. Now, hmm, so our requirement was AB plus CD, right? So AB plus CD, it was the requirement. So we have this as a match, but CD expression we cannot get. The reason being that there is one CD expression which is associated with A. So this is not the correct answer. Fine. Now let's move to option B. So there is a possibility of getting AB. There is also a possibility of getting CD. Fine. So first we will multiply these two, then we will multiply these two. Okay. ABD plus AD होना चाहिए. Hmm, yeah, I actually made a mistake. Hmm. 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 So इसको और simplify कर सकते हैं now. We can club these two. Okay. So AD, if we take common, it will be AD 1 plus C, BD plus BC. Okay. So it is AD plus BD plus BC. And our requirement was AB plus CD. Okay. Which is not equivalent. Fine. So first we will multiply. So we will multiply all, but we will group these two. Okay. We will group these two and these two. Fine. So it will look like AB plus AC plus BC plus C, and that expression will be AB plus AD plus BD plus D. Okay. Now we have AB plus, we can take C common. It will be A plus B plus 1, AB plus D common, A plus B plus 1, and this expression is 1. Okay. I hope there is no doubt in this. So it will be AB plus C, AB plus D. Now it will be AB plus ABD plus ABC plus CD. Hmm. I think तीनों को कॉमन लेना है. Okay. This will be 1. So this is the answer. Moving on to the next question. Okay, so I will give you 5 minutes to solve this, and I hope there is no doubt in the previous question. Okay, um, I will discuss the solution in 2 minutes. So I will discuss the solution right now. Okay. One need not even solve this question because you can see from the options that I hope everybody agrees that signal A in the output expression is not possible at all, because in this expression signal A is not there, A bar is there. Okay, so any expression having A is invalid. Fine. Similarly, okay, I think I should solve. It would be better. So first I will perform multiplication in this. You can take A dash common. Okay, This is the answer then. I think my screen froze. Fine. So option C is the answer. The reason I was saying that there is no need to solve the question is that, as you can see, that any option having a signal A. So this is my question, right? And as you can see, there is no A signal. So here, so here you can see that this has A option. So this cannot be your answer. Similarly, signal A is also there. This cannot be the answer. Fine. Now there is no signal C bar as well. But as you can see here in the answer, there is C bar signal. So this is not also possible. So the only answer that remains is this. Okay. So in this question, you do not even need to solve this. Okay. You can look at the question and know the answer. Moving on to the next question. Okay. I will give just 2 minutes to think before moving on to the next question. Okay. So a K-map is basically, I will discuss the solution. So the K-map is basically what? A map of all possibilities of a signal. Okay. Of each signal. So suppose I have A, B, C, like n signals if I have. Okay. So my signal A can either be 0 or 1. Similarly, my signal B can be 0 or 1. My variable C can be 0 or 1. Okay, like that. So how many? So for each signal, there is two possibilities. Okay, and how many such signals are there? Suppose there are n signals. So the total possibilities would be 2 power n. Okay, 2 multiplied by 2 n times, which will be 2 power n. So this was a very simple question. Okay, moving on to the next question. So I will give you 5 minutes to solve this. So I will give you a hint. Okay, so when we talk about prime implicants, so we always talk about grouping of 4, 2, or 1, which do not overlap if possible. Okay, so in this case, we can group like this, we can have a group like this, but we will not make a group of this because first of all, this is a redundant. Okay, we have already counted these one in the rectangle box, so we will not make a square box. Similarly, here prime implicants would be this one and this one, okay, and this one. See, we cannot pair this single one with anyone, okay, so this will be a prime implicant on its own. Then we have this case and this case, okay. We would not make this because it is not at all required. Fine, because we will be counting it twice. In order to have a most simple expression, most reduced expression, we will have less number of groupings, okay. There will not be any overlap. So anyone got the answer for this? If you need time, let me know. I will discuss the solution in 2 minutes, okay. And in the beginning of the tutorial, I forgot to mention the contents which we will be discussing today. So the contents will be Boolean expression, simplifying Boolean expression, K-maps, and logic gates. Okay, so the initial questions will be regarding Boolean expression, okay, and K-maps, and later we will see logic gates. Okay. I hope you have solved. I will discuss the solution now. So the question is, we can make a K-map for this. Okay. So this cell, the value is 0. This is 1. This is 2. This is 3. This is 4, 5, 6, and 7. Okay. So we have values at 1, 3, 4, 5, and 6. Okay. So now, if I have to make the pairing of, I can pair, sorry, I can make groups of 1, sorry, if it is single, it would not be called groups. So I can make groups of 2 and 4. Okay. So one group I can make like this, another group would be like this. Third, either we can make like this, or we can go like this. Okay. So first two is clear. It will be, so if you look at this, so this will be A, C, this will be A bar, sorry, this is A C dash. Okay. This will be A bar, C. Now we have two options. We can go with this, which will be A B bar, or we can go with this one. Okay. Which will be B bar C. So what are the possibilities? A C bar, A bar C, A B dash. Okay. Another possibility is A C bar, A bar C, and B bar C. I hope this works. Uh, is it clear to everyone how we reach the solution? Fine. So moving on to the next question. So this is the question. I hope this is clear. You have to make the you have to basically write the sum of product expression for output equal to 1, which is fairly simple. So I will discuss the solution in 1 minute. Fine. I am discussing the solution. So as you can see here, Q can only be 1 if this is the input. Now if I have to write an expression, I cannot write ABC because it will be 0 into 1 into 0 equal to 0, but the requirement Q is 1, so I have to modify it. So my expression can be A bar B C bar, so that it will be 1 multiplied by 1 multiplied by 1 equal to 1, which is same as Q. Okay, so in this case we have to select all the cases where the output is 1. Okay, so this looks as A B C. This is A bar B bar C. This is A B bar C bar, and this is A bar B C bar. Okay, so which is I think quite similar to this option. Okay, A B C. Fine. So I think this is clear to everyone. I will move on to the next question. Okay. The question is fairly simple. The number of minterms after minimizing the following Boolean expression. Yeah, I think someone has raised their hand. Do you want to ask something? So I will give you 5 minutes to solve this question. Okay. Well, the solution I have, it says that the answer is A, but we will check. Okay. So I think I should discuss the solution right now. Is anyone trying right now? Should I wait or should I discuss the solution? The answer is A actually. Has anyone got A? Fine. So I will discuss the solution. Okay. You can see there is that there is C dash T and there is also C dash T. So we can club this together. Okay. So it will look like D dash plus AB dash plus this will be equal to D bar plus A B bar plus A bar C plus C bar D. Okay. Now we can club these two together as if you make a Venn diagram. Okay. This is suppose C and this is D. Fine. So first expression says D dash, which means okay. So this expression says C dash D. So C dash means outside the circle C in which is common to D. So this is your C dash D, and D dash means this area. So if you look closely, this is similar to CD bar. Okay. So we can write A B bar plus A bar C plus CD bar, and we have a whole bar over here. Now what we can do is that we can club these two together and we can make keep it separate. So as per De Morgan's law, we know that A plus B bar is equal to A bar dot B bar. Similarly, if we have A B bar which is equal to A bar plus B bar. Okay, I hope everybody knows this is this. Okay, so everybody knows this. Now we can club this together. So it will be like AB bar plus A bar C bar dot CD bar bar. So which will be CD only. Okay, so this will look like AB bar plus A bar C whole bar into CD. So this expression, so we can again apply this here. So this will be AB bar whole bar into A bar C whole bar multiplied by CD. Now in this case we will apply this one, which will be A bar plus B bar bar multiplied by A bar bar plus C bar into CD, which will be A bar plus B A plus C bar into CD, which will be, see, if you multiply A bar with A, it will be 0. Okay, A bar into A is equal to 0. So what we have right now is A bar C bar plus AB plus BC bar multiplied by CD. Again, when C multiplies with C bar, it will be 0. Same with this case. So our answer will be ABCD. So this is the only min term we have. Okay. So option A is the answer. Moving on to the next question. Fine. So this is the question. So whenever, so I will explain this part. Okay. If anybody is not sure about this, so this D represents don't care. Okay. So if this is my K map, and suppose randomly I have signals like this, and if I have don't care like this, okay. So this means that whether this position, if it is 1 or 0, it does not matter to the system. So according to our benefit, we will assume it either 1 or 0 so that we can simplify the expression. Okay. For example, if, so suppose in the don't care position, I assume that it is 0. Okay. And in another condition, I assume that the don't care is 1. So as you can see that in this condition, when I assume don't care as 0, it is difficult for me to make the circuit. It's not difficult, but the expression will not be simplified. Whereas in this case, I can group all of them, and I can group them as well. Okay. So it will lead to a very simplified circuit. So I will give you 2 more minutes to solve this. So another thing I would like to mention, that for example, if it happens that this position is also don't care, okay. So in that case, if you assign 1 over here, it would be problematic for us to simplify it. For example, this one cannot be paired with anyone else. Like if you pair with this one, it will only increase the number of circuit elements. Okay. So it is better for us to assume that this position is 0. So I will discuss the solution right now. Fine. So how can we group them? So as you can see, we make square, rectangle, either 4 cells or 2 cells. These will be 4 cells. Okay. So I can. So this is the one. We can have another one like this. Okay. And one this. So my simplified expression will be a bar d plus this row, which is a bar b bar plus this column, which will be cd. But as I mentioned earlier, uh, this a bar b bar is redundant, because if we assume this don't care to be 0, our expression will be further reduced, okay, which can become as a bar d plus cd. I think I made some mistake. mm, this is a bar and d and cd. Okay, this is fine. Yeah. Okay, fine. What they did was, they did not consider, like they considered this as 0. So in that case, you will have two rectangles. You will have this rectangle and you will have this rectangle. Okay, so in that case, this term will be eliminated. So you will have the answer as a bar b bar plus cd. Both of them are actually correct. Okay, so a bar b bar plus cd, this is the answer. I hope this is clear to everyone. I will move on to the next question. So given a k map, what is the most reduced, 1 second, sum of product expression? Okay, so the k map that you have is this one. Assuming rest of them to be 0, can you tell me what's the answer for this? I think this is fairly simple. You can type in the comment section. So do you want options or what? So I think instead of YZ you mean XZ. Fine. I will discuss the solution. This is a very simple question. So what we have over here is that, so we can do like this. We group these two together and we group these two together. Okay. Any other combination will only increase the number of expression. Sorry, increase the number of terms. So it will actually increase the size of the expression. So this will be your function f will be x bar x bar okay, x bar y bar plus x z. Fine. Now I repeat the same question, but this time the only thing that is different is that what is the most reduced SOP expression without hazard. Okay. Uh, are you aware about hazard? Because this is very important. So will there be any difference in the expression? So I will give you 2 minutes to think. Okay. So hazard, I would give a hint. Hazard means that whenever there is a signal transition, we want the output to be stable without any glitch. Okay. For example, if I am transitioning from this point to this point, okay, which means that my signal y changed from 1 to 0. So I want that my output should be 1 despite the change. Okay, if I move from this point to this point, still my output should remain at 1. It should not fluctuate, even for a very short period of time. Similarly, for this transition. So I think I will explain this question. Sorry, I think I will. Yeah. Okay. So the answer will be this. So the expression will be plus xz plus y bar z. Okay. The the reason behind adding this term is that we don't want any glitch. Okay. For very sensitive systems, for example, emergency alarms, and uh, for example, in industrial plants, you do not want the alarm to go off randomly, right? So you do not want glitch in those kind of systems. So there you are not really focused about simplified boolean expression. There you are more concerned about no matter what happens, no matter any kind of signal fluctuation, uh, your there should not be no false alarm. Okay, so there we deliberately add extra terms so that there is no glitch. So right now people generally teach that you add this one and there will be no glitch, but I think it will be fairly difficult for you to imagine like how this operates. So I will explain that here. For example, you have signal xyz. Let's take two cases. Okay, so we have signal as, if you are moving from this point, this position is if you are moving from this point, how do I mark this point to this point? Okay, from this point to this point. So what are my signal values? Suppose I mark it as 1 and mark it as 2. Okay, so for 1 my signal values will be 101, and I move to point 001. Okay, so right now I have two expression, x bar, y bar, and xz. Okay, and then I have final f. So this term will be what? X bar, y bar, it will be 0, xz will be 1, so your final output will be 1. In this case, x bar, y bar will be 1, xz will be 0, final output will be 1. So earlier I mentioned that there will be some glitch, but right now you cannot uh, see the glitch. The reason being that we are assuming that whenever there is a from transition in x from 1 to 0, your x bar will go immediately have the transition from 0 to 1. Okay, suppose I have a circuit like this. There are some inputs. Then I have, in order to generate x bar, I will have an inverter. Okay, which will generate a x bar. This is x bar, and this will be fed into another circuit, which will have y bar, z bar, suppose anything. Okay, and this will give you the output. Suppose this is SOR. Let's assume this is x. Uh, Here you have AND gate. Fine. And here you have x bar, y bar. Okay. So here we are assuming that whenever we transition this x from 0 to 1, in this case we are doing from 1 to 0, immediately this signal will also go from 0 to 1. But that is not the case, because here is an inverter which will have its own delay. Fine. So what will actually happen is that this will go from 1 to 0, but your x bar signal will take some time. It will be 0, it will remain at 0, and then it will go to 1. Okay, so the reason behind that is that there is some delay in it. Now if you look at this expression, it has changed. So in this case, x bar, y bar is 1. If you look in the middle situation, x bar, y bar is,
Please explain from the beginning.
sorry,
Not getting it. Not getting this. Can you please explain from the beginning?
okay, fine. Hmm. Whenever you have complementary signals, for example, here you have x, and in the same expression you have x bar. Fine. So in that case, what happens is that your circuit will look somewhat like this. You have the x signal over here going into AND gate, then you have x bar signal, but you have to get the x bar signal from somewhere, right? So for that you have to pass the x signal from through an inverter, which will convert x to x bar. So this point is x bar, which will go to the AND gate. So if you look at this expression, this is basically x bar, y bar plus xz. So y bar is coming from somewhere. So this is x bar, y bar plus this is OR gate, and this is xz. Fine. So the problem is that whenever you are doing this transition from 1 to 0, there will be some delay by this inverter to convert this 0 to 1. Is that clear? So for a very small amount of time, what will happen is that when this x has gone to 0 and this 0 has still not gone to 1, your x and x bar both will be 0. Is that correct? We are assuming that the circuit is digital, but eventually all the processes are happening in analog way, right? And in analog, the transition takes some time. Even the transition time might be in nanosecond or picoseconds, but there will be still some time. Okay, is that clear? Okay, I will explain again. So you have this signal. This is x, this is x bar. Okay, so earlier it was 1 and this was 0. Now you swiftly change this to 0. Okay, but this inverter will take some time. Suppose this is t is equal to 0, this is t equal to delta t. you swiftly change this. So this x is under our control. Okay, so we can change it as the way we want. So for at t equal to delta t, we change this to 0. Okay, but at this point, this will x bar will still be 0 because the inverter will take some delay. Suppose the delay is td for the transition to happen. So at t equal to delta t plus td, this will be 0 and this will become 1. So for this very small instant of time, you will have x and x bar both as 0. That's the problem, and this will lead to some glitches. That's what I'm saying. If you look at this point, so now here we are discussing the transition phase where x bar is 0 and x is 0. So in that case, what will happen to x bar y bar? It will be 0. And what will happen to xz? It will be 0. So in that case, your output will be 0. So your waveform of f will look like somewhat like this. It is initially 1, it will go down to 0 for a certain while, and it will come back. Fine. Suppose this is your x signal and you have made the transition, okay, from 1 to 0. So your output signal will remain at 1 initially. After the transition, it will remain at 1 also, but for a small duration of time, it will go down to 0. So this actually causes some problem. Okay, you do not want, actually you want your circuit to be very much resilient to glitches, and so this can actually cause problems when you have, like if you have made this kind of circuit uh, in emergency alarm circuits. Okay, so this might cause some problem because even though there is no emergency, it might raise false alarm. Okay, so we want the circuit to be resilient to glitches. So it is suggested that you add this extra expression, which is y dash z, which is basically this portion. Okay, so if you add that, then you would not find glitch. I will show you how. So let's copy this. Okay, so suppose in this case you have y dash z. Yes, y dash z. So what will happen? So in this case y dash z is 1. In this case y dash z is also 1. Okay, and in this case also y dash z is, this is y dash z. Okay, so this is also 1. So in that case you will get 1. So because of adding this extra element, we won't have any glitch. Our output will be constant. So is that clear to everyone? Why adding this extra term makes the circuit hazard free? So it will be mentioned in your question whether you have to make the simplified circuit or simplified circuit without hazard. Okay, it will be clearly mentioned. So yeah, I hope this is clear. I will move on to the next question. This is a simple question. So I will give you about 5 minutes to solve this question. Fine. So is there anyone still trying this question? Uh, or should I discuss the solution? I'm discussing the solution right now. Okay. First, I think we have to make a K-map. So 0, 6, 8, 13, and 14. We have don't care at 2, 4, and 10. So how can we do it then? First of all, we can make a square like this. Fine. Then mhm, there is this one square. We can make another square like this. We can make a rectangle like this. And this is the independent one. Yeah. So I have mentioned B, C, D, B, C bar, T. So Swatika, you have mentioned that there can be a term B C dash D, but the problem is that it is not possible because this term you can see here. This is A B C dash D, okay, and for yeah B C dash D you need at least one more one. For example, at this place, okay, यहाँ पे होता तो B C dash D possible होता. Fine. So writing the answer. it will be a b c dash d plus, let's take this square, it will be mm, b bar and d bar, fine, plus taking this square, it will be this, suppose this is 1, this is 2, so this square will be a bar and d bar, fine, and this rectangle, it will be c d bar. Okay, so this has many redundant expression, so let's check our options. So we have a b c bar d, fine, then we have c d dash, then we have b dash d dash. This term anyway it's not relevant because this is redundant. Having it in the expression and not having it is the same thing. Okay, so this is the answer. So moving on to the next question. Fine, I will give you 5 minutes. So I'm extending the today's session because I started my recording about I think 15 minutes late. Okay. Yeah, the answer is actually 15. I think this is a fairly simple question. For example, I will discuss the solution right now. Okay. So you have ABC, A B bar C D plus C F and AD. So for this you need three input and you need four input, two input and two input, and then you will need four input, or this will be 3 plus 4. I will give you one last question, then I will end the session. This will be regarding gate. The reduced circuit of the following. Options are Fine. I will discuss the answer in 2 minutes. This is AND gate. Yes, someone has raised hand. Is there anything do you want to ask? So I will discuss the solution. Okay. So for the first OR gate, the expression is A B bar C bar, A plus B bar plus C bar. Second OR gate, it is A plus B bar plus C. When you perform AND, it will be hmm. I think this will be simplified to A plus B bar. Okay. The trick is that if there is some expression with another signal and you have the same expression, sorry, if you have some term with another term and you have in repeat that term, but this time there is a complement, so it finally gets cancelled out, and this is the term that remains, so which is equal to this part. Okay, so D is the answer. So that's all for today's tutorial. I'm stopping the recording right now. If you have any other questions to ask, feel free to do so.